Hi everyone. Today I'm going to start a new playlist which includes problems from a book called Guide to Competitive Programming. So I have already gone through the book once, around 1.5 years back, and I'm revising it now. So I thought, why not, uh, why not create videos and help others to easily other like rather than going through the entire book and reading it, they could easily go through these videos and understand the basic concepts required for cracking a in coding interview. Okay, so I'm not going to go through the details of how we could find complexity, etc. I'm assuming that you are aware of it and how to do it. So let's jump right in. So the first problem that I will be discussing here is generating subsets. Okay, so let's see how we generate subset. So I'm going to write a array. I'm just taking an example here. 1, 2, 3. What is the subset of this array? So uh, empty set 1, 2, 3, then 1, comma 2, 1, comma 3, 2, comma 3, and the last superset which includes all the elements 1, 2, 3. Okay, so how many subsets does this particular array of length 3 has? It has 1, 2, 3, 4, 5, 6, 7, 8. So it has 2 to the power of n, where n is the number of elements in the array. Okay, so what is the observation that we can make use of? So if you look at the first one, we take none of the uh, elements to this list. Then we take the zeroth element. Then we take first index element. Then the second one, and we take first and the second, like zeroth element and the first element, and zeroth element and the second element in the array. Then first element and the second element, and so on. So how do we, so if you look at it, there are combinations of all the decisions here. So we decide whether to take an index element or not. From this, I'm going to write a decision tree so that we can come up with a program. Okay, so I'm going to call the program as, or the call the function name as search, because we are searching for the subset. Or we could also say backtrack or whatever you want. So I'm going to call it as search. So let's see how it looks like. So here I call the function with say 0. Okay, and this is the this is the decision tree. So at every point, what should we do? We decide whether to include an element to the subset or not, right? That is how we come up with all these 8 decisions or 8 subsets that we created from the array 1, 2, 3. So should we take the 0th element or not? Okay, let's take it. I'm just putting a tick mark here so that you know whether we are considering it or not. On the right side, we will not take that particular 0th index. Okay, so the subset is going to be, we are considering the 0th element. So the subset now is 1. Here the subset is empty. This is, now we have reached the second stage. Here as well we have 2 decisions, right? Whether to take it or not. Okay, so the left side decision means we are considering it, right side means we are not considering it. Okay, so what would be the value here? So the subset is going to be 1 and 2. So we reach here. Here we are not considering it, so the subset is still 1. What would happen here? So here as well we are considering on the left child, and on the right we are not considering that. So this is the 0th index, this is the first index, this is the second index. Okay, so we are considering the second index. So 1, 2, 3. So we are considering it. Here we are not. So it would become like we have 1 and we are not, we are at 1, 2 and we are not considering it. So the subset is 1, 2. When we start with 3, is there a third index with the third element? No. So that means this has finished at this level. Okay, iteration, and here as well. Let's see what would happen here. So we have in the subset 1, and similarly we have 2 decisions to take here: consider it or not. So this is the second index, so we are considering it. So 1 comma second index is what? 3, and we are not considering anything here. Okay, so 1, 2, 3. 1, 2, 3. So we have finished here and finished here. What would happen here? So the index is 1, we are considering it here, we are not taking it here. So the subset would become, we are taking the first element. What is the first element? First element is 2. Here we are not considering it, right? So it is still an empty list. So the next iteration is index 2. So there are 2 decisions here, there are 2 decisions here. Here we are considering the second index and here we are not. Here we are considering it, here we are not. Okay, so what is the second element? Second index element, that means 0, 1, 2. Third element is the second one, so we are taking it. So the subset would become 2, 3, and here we are not considering it, so the subset will be just 2, and here we are taking this second element, so it would be 3, and here we are not taking, so it would become empty. So how many subsets do we have? 1, 2, 3, 4, 5, 6, 7 and 8. So we got it, right? So let's take a look at the code and see how we can implement this. Okay, so I'm using my Visual Studio Code here and creating a file called generatesubsets.py. Okay, so let's see how we implement it, right? So I'm going to define a method called generate subsets, and the list is named as array, and when you look at here, how do we know when to stop the calling, right? So we call with 0th index, first index, second, and we reached here. So we prune it, or we stop the iteration when we have hit the number of elements in the array. So let's see, let's find the number of elements. It is n is equal to len of array, and So we need to store these elements in a subset, or we need to store it in an intermediate data structure. So I'm going to keep it as an array here, which is called a subset, and we need all the subsets, right? So I am defining again an array called results, which will have all the subsets of the array given. As I said, I'm going to name it as search. And what is the input? So let's call it as k. So k is the index element. So every time we decide whether we need to include it in the subset or not. Okay, so when do we stop it? So let's write the termination condition. So if k is equal to n, that means we have reached the end of the iteration here. Like for example, either here or it comes here, and so and so. Okay, so if k is equal to n, what should we do? So results will have the subset, right? So we are going to add the subset here. Why are we using subset of this? In Python's subset of this is kind of creating a copy of it. Why are we creating a copy of it? That is because in Python each variable is a reference. So since we are doing it in a way through recursion, it will end up being the same value at the end whenever it stops. But in our case, we want all the results, right? So I am taking a copy of it, that is subset of array. So the whatever was subsets element at that particular calling time, when k is equal to n, we are creating a copy and adding it to the results. And in the else case, what are we going to do? So let's see. So we are adding the value, right? So we are adding the value, that is this left decision. So we are adding this value. Subset dot up and off, what are we adding? Array of k, right? And then what do we do? Then we proceed with the rest of the computation. So we call it recursively. What do? We start with the next index, right? So for example, it comes here, here, and here, and at the end, what should we do? We should go back, right? How should we go back? So we have to pop this last element that we added. So what do? We do here like subset dot pop, and then we do k plus 1. So I'm just adding a comment. So we are adding kth element to the subset. Here we are not adding kth element to subset. Okay, so this is the method, and we have to call this, right? So how do we call? We start with 0, search of 0, and by the end of the execution, what do we have? So we will have the results with the subset. Okay, so let's see how we can do it, right? Okay, so I'm going to call this array is equal to, as we said, 1 2 3, and what do we want to say? Want to print of generate subset of array. Okay, let's execute this. Okay, so we got this. Okay, let's see the order. So if you see, we got 1 2 3, then 1 2, then 1 3, then 1, then 2 3, then 2 3, and 1. We can do this in reverse as well, meaning that we can actually we can switch between this, like we can start with not adding it and then adding it. So let's see how would it look like. So we are not adding the kth element, then we are adding, then we are popping. Okay, so let's see how this goes. So we got this in reverse: 0 3 2 2 3 1 1 3 1 2 and 1 2 3. Okay, so we can do it in either way. Okay, so I'm going to reset the canvas and go through how else we can do it. Okay, so now you know how to find the subset. Is there any other way to do it? So how many subset does an array have if the array length is n? This is 2 raised to n. Do you have an idea of how this would? So I also mentioned that a decision tree is something that you can look at. So we decide whether to include an element to the subset or not, right? So any clues? Okay, so let me tell you how we can do it in a different way. So I'm going to take the same example here. 1 2 3. Let's look at binary numbers, right? 0 0 0. Then we write 0 0 1 0 0 sorry 0 1 0 0 1 1, then 1 0 0 1 0 1 1 1 0 1 1 1. How many entries does this have? 1 2 3 4 5 6 7 8. From this, can you make sense of how we can generate subset from here? So for example, all of this is 0. That means we are not adding any of the index or any of the elements. So here, if you look, we can say 0 1 2. So we can add 3 here. Similarly, we can add the middle one here. So 2 here. Here we can add 2 and 3 because the bits are 1 here, and here we can add 1. Here we can add 1 comma 3. Here 1 comma 2, and here everything is 1, so we will add 1 2 and 3. So ultimately what we wanted was a decision based on which we can decide whether we want to include an indexed element or not, right? So we could use this binary representation to consider or generate subset. Okay, and I'll code it and show you how we can do it, right? And before that, I want you to know a couple of more things. One, we need mechanism to kind of check whether an index is whether a bit at this particular position is set or not. And if it is set, that is when we add that particular element to the subset, right? How do we check it? So how many, so whether so this array has 3 elements. So how many subset would it have? 2 raised to n. How we can either mention it as 2, like we can do it like 2 to the power n, or we could do something with a binary operation, which is 1 and left shift of n, right? So this is equivalent. Okay, and how do we check whether an index is whether a bit at a particular index is set or not? So we could use something like similar to this, but we have to see how do we know whether, say, second element here, this one is set or not, right? So what we can do is 1 left shift, say second let's see m, where m's value is 1 in this case, right? And we we add this particular value, which is 0 1 2, right? 2, and this value is true, is true or not. Okay, so ideally, what is 2? 2 is 0 1 0, and 1 left shift M means what is 1? 0 0 1, right? I'm going to do a left shift to here. Okay, so this is going to be 0 1 0, and this would be valid if the middle what is it, bit is set or not. Let's take another example. This is the basic of how we would do it. Okay, so let's see how we will code it, right? Okay, so I'll write it on top. I'll rename it so that, yeah, so okay, n is equal to array. Okay, so we'll create a mask. So we can say mask as initial mask as 0, which is the starting value. Then results would be an array which will store the subsets. Then while, so we are going to iterate from 0 to 2 raised to n. So mask less than, you can either use this or you can use 2 to the power n. So I'll stick to 1 left shift n. Okay, so we need an array to store the intermediate subset, and we need to iterate through the length, right? We have to iterate through the length. For I in range of n, if b is if mask and 1 shift I, that means that particular bit at that particular ith position is set. So if that's the case, we would append it to that array. So we are adding it to the subset. So we got one array. So once this is done, that means one iteration is over. So results dot append of subset. Then we will add +1. Then return results. Okay, so there's a different way we could do this. We don't need to set it as mask. So you can just do it with, for example, for I in range of 0 to 2 raised to n, and then do the same. Okay, so let's try executing this. Okay, so we renamed it like this, so let's use it. Oh, sorry, so I meant mask here. Okay, so we got all the subset, right? So this is another way of finding subset. So we can either use binaries. I can show you another way you could write this loop. How is it? So you can do for I in range of, it will starts with 0 and 1 less than n, then subset equal to this, and for I in range of n, if so there is 2, so yeah, mask in range. So if mask and 1 left shift, that means whether so initially is the 0th element set, that is 0th bit is set. Okay, not element, I'll say bit set. Then first element and then second element, and so on. Okay. If it is set subset dot append of array of I. Okay, so once that loop is done, we would get a subset. Okay, then that's it. Then we would return results. Oh, okay. So something we need to find out here is this only runs from so this is not inclusive, right? So we need that to be inclusive. So we'll do 2 into n. This is same as 1 left shift n. Okay, plus 1. So let's try execute. Okay. Oh, sorry. So we just need to rest n. Okay, yeah. Okay, so let's go through this again and understand what happens. So I'll write it in command here. So the mask is 0 initially. Okay, basically 0 0 0. Okay, and it checks if either one of this like 0th element, this is 0, the rightmost one, 0 1 and 2 is set or not. So initially none of this is set, so we will add an empty one. Then mask would become 1, right, because we are iterating from 0 to 2 raised to n. Okay, so yeah, this is also fine. Okay, 0 0 1. So here we are checking 1 left shift 0. 1 left shift 0 is 0 0 1 and 0 0 1. So this is true. So we will add the 0th element. So we would get what, 1. So the next mask is going to be 2. What is mask in bit? So 0 1 0. Okay, then we are going to do 1 left shift 2. So 0 1 0, it is set, the value is 2. Then mask is 3, which is 0 1 1, and we are checking whether so whether a bit is set by doing 0, which is mask 0 into 1 what is 1 left shift 2. That means 1 is here, so when we shift 1 to 1 and 2 places, it would be 0. Then we'll add 3 and so on. So that is how we find out. Okay, yeah, so that is the end of this video. Thank you everyone. I hope this is clear. Please let me know if you have any confusion, or if you didn't understand, and if you have any feedbacks. Everything is welcome. So I'm new to this, so I'm learning along the way. So yeah, thank you so much, and see you in another video pretty soon. Thank you. Bye bye.